The next topic that we're going to look at is composite functions. So let us take an example. So let us take that we have two functions f and g. F is defined from the set A to set B, and g is defined from set B to set C. Now, let us say that set A is 1, 2, 3, set B is AB, set C is 4, 5, 6. And F connects 1 to A, 2 to B, and 3 to B. So is it a valid function? Yes. Every element in set A has a unique image in set B. And let us say that the function C, the function G, connects A to 5 and B to 4. So now you have the function F from A to B and the function G from B to C. So now, can I define a function from set A to set C, which looks something like this. So for every element x in A, so first I'll find f of x. So for every element x in A, you have an element y in B, which is f of x. And for every element f of x in B, can I find g of f of x? Yes, right? So if you take an element 1, what is f of 1? So f of 1 is nothing but A. And can I find g of f of 1? G of f of 1 is, f of 1 is A, g of A is equal to 5. So what is g of f of 2? So f of 2 is B and g of f of 2 is equal to 4. And what is g of f of 3? G of f of 3 is, first f of 3 is equal to B, that is nothing but g of B. And what is g of B? Is equal to 4. So I can always define a function which looks like g of f of x, which can be defined from set A to set C. So this composite function is called GOF of x. So GOF of x, GOF of x is the function defined from set A to set C, and GOF of x is nothing but defined as g of f of x. So you have to understand that the function is defined in the reverse order. If f is the first function and g is the next function, the composite function will be GOF of x. That is, if you take it in machine interpretation, so a composite machine is a series of machines. So let us say that you have a machine f which takes in the value of x and gives out the value of f of x, and you have a machine g which takes in the value of f of x and gives out g of f of x. This sequence, this series of machines, this double machine is called the composite machine, composite function. And what is the name of this function? GOF function. So you have to go from back to front. GOF function has f first and g next. So in this way you can also composite more than two functions. If you have another function h which goes from C to D, you can define h of g of f, HOGOF, composite function, and it is a combination of all the three functions. Let's go forward. So for example, so if f is a function from real numbers to real numbers and g is also a function from real numbers to real numbers, f of x is defined as 2x plus 3, g of x is defined as x square plus 7. Now you need to find x such that GOF of x is equal to 8. So by the definition that we have learned, GOF of x is nothing but g of f of x, right? So what is g of f of x? G of f of x is given as 2x plus 3. So g of 2x plus 3 is nothing but, so g of x is x square plus 7. That is, if x goes inside g, so it squares that number and adds a 7. So if 2x plus 3 goes inside g, the value that comes out is 2x plus 3 whole square plus 7, right? So GOF of x is 2x plus 3 whole square plus 7, and this is given as equal to 8. You're asked to find the values of x which satisfies. So let us solve this. So you get 4x square plus 12x plus 9 plus 7 is 16 is equal to 8. So 4x square plus 12x plus 8 is equal to 0. This implies x square plus 3x plus 2 is equal to 0. So this is a quadratic equation. So this can be factorized as x plus 1 into x plus 2 is equal to 0. This implies x is equal to minus 1 or minus 2. So GOF of x is equal to 8 implies x is equal to minus 1 or minus 2 is the answer. So next, the basic properties that you need to know about composite functions are FOG is not equal to GOF. This is quite obvious, right? So if you take GOF, so if you take the example of the previous function, f of x is 2x plus 3 and g of x is x square plus 7. So what is FOG of x? FOG of x is nothing but f of g of x, that is f of x square plus 7, that is equal to 2 times in the place of x you need to put x square plus 7 plus 3, that is equal to 2x square plus 17. And what is GOF of x? It's nothing but g of f of x, that is nothing but g of 2x plus 3, that's nothing but 2x plus 3 whole square plus 7. So obviously you can see that these two expressions are not same. Hence these two are not equal functions. GOF is not equal to FOG. And that means commutative law is not valid. And the second property is associative law is valid. That is, if you don't change the order of the functions, GOF OH is same as GOF OH whatever bracket you put. So first you calculate GOF and composite with H, or first you calculate FOH and composite with G. So as long as you don't change the order of the functions, bracket placement does not really make a difference. That is, associative law is valid. Associative law is valid. And the third property is that, so if you composite any function with identity function, you get the same function itself, because GOI of x is nothing but g of I of x. And what is I of x? I of x, I is an identity function which is defined as y is equal to x. So I of x is same as x, so that is same as g of x. So GOI is same as IOG is same as g. So these are the properties of composite functions. So now let us go forward.